welcome to this tutorial. In this tutorial we're going to continue our exploration of the question why binary, hence why binary part 2 on the screen. Now previously we looked at the 7-segment display, there it is, showing the letter or the value 0 at the moment, and we looked at that and how that can be represented in a computer system, and it's a series of transistors having values 0 and 1. What we're going to look at this time around is a little bit deeper. We're going to look at the truth table that would be used to test out to control, if you like, our 7-segment display. Now, we can see on the right hand side of the screen that I've got a red value 8, or red number 8, and it's broken down into 7 segments, hence the 7-segment display. And it's standard practice to label, to annotate each segment separately. So I've got A, B, C, D, E, F and G. And that helps us to identify potential outputs. So A, for example, is an output, B is an output, C is an output, D is an output. Now notice that it's lowercase a to G as opposed to uppercase for the input. So, well, let's have a look at this. If we look at the screen, the left hand screen, our 7-segment display is displaying 0, and that's because all of the inputs are off. So if we look at our truth table, now when we come to truth tables, remember the formula 2 to the power of n to calculate the number of rows in your truth table. Because we've got 4 inputs, D, C, B and A, that's the n value, which is 4, so 2 to the power of 4 is 16, 16 rows required in our truth table. So let's have a look at this value 0. Well, what it needs is D, C, B and A as inputs to be switched off, and what that will then do is switch on all of the inputs apart from G. So let's check. So A, B, C, D, E, F and G. So G off, that gives us the value 0. So let's check our value 1. Well, there's 1. Well, so that means D, C, B and A, D, C and B are off, and A is on, or has the value of 1 if we were talking binary. Well, D, C, B off, A is on. Okay, so what that means is that all of the segments would be switched off apart from B and C. So let's have a look at our truth table representation. Well, A is off, B is on, good, C is on, good, then D, E, F and G are off, as it should be. Okay, let's go to the top of the scale. Let's go to 9. So how do we represent the digit 9? Well, 1001 in binary, or for our system, D is on, C is off, B is off, A is on. That gives us 9. Now, let's have a look at the 7-segment display. Well, we can see that on the 7-segment display, all of the segments are switched on, or have a value of high, apart from segment E. So let's have a look at that. Well, so there's 1001. Well, that's the value 9, or corresponds to D on, C, B off, A on. And its output value, well, A, B, C, D are on. E is off. That matches what we're doing here. Oh, F is on. Yep, and G is on. Okay. So that gives us our standard digits from 0 to 9. But remember from last time, we also incorporate values up to 15 using hexadecimal with our 7-segment display. So let's switch on the value 10, or A for hexadecimal. Well, that would be D on, C off, B on, A off, or 1010 in binary. So let's have a look at that. Well, there's our display A. Well, okay, so D on, C off, B on, A off. Okay, and what that means is that all of our segments should be switched on apart from D. So let's check our truth table on that. So A on, B on, C on, D off, E on, F on, G on. Okay, so we've got our truth table representation for the value, or the display A. Let's go to the top of the tree for hexadecimal. Let's switch all of our inputs on. Now that's using typical convention. That's the bottom row of our truth table. So all of our inputs, switched on, and that should give us the value F. Should display F on the screen, which it is on the left hand side. And what that means are segments B, C and D should be off. Well, let's check. Well, A is on, B, C, D off, E, F and G on, gives us the value F. So as we can see, In order to control a 7-segment display, if we use 4 inputs, requires that we have 16 possible variations on that. All of them have a very different set of inputs, of course, to produce the range of outputs on the screen. Now, if you imagine, that's just one 7-segment display. On many calculators, you could have several 7-segment displays, and each of those would require control through a hardware system, ultimately boiling down to transistors, which are interpreted as binary to control the systems. So, well, thank you for looking at this. So, if nothing else, you now know something about 7-segment displays and how they can be represented in truth table form, and also, of course, creating them as an annotated diagram. Thank you.